Hello, Professor. I'm trying to upload a little bit shorter video. I was not able to upload the longer one that I took earlier for some reason, but I am doing the video on the Module 3 Critical Thinking about greenhouse gas and how it is affected and what our lab looked like. Our lab was just based on 2 glass jars. We had one that was filled with a CO2 mixture, and then we had another one that was just fed with a light source. Both of them were hit with light sources, but only one of them was allowed to have the CO2, and then we took the temperatures of those, and we were trying to see if what the difference of those was. I will start out with showing you what my graph looked like for those. This is my graph. My graph shows the differences of how the temperature rose with the carbon dioxide compared to how it rose with the air. I did the temperature in Celsius on this side, the time in minutes on the bottom, and then just clarified what it was on the top. My hypothesis for this experiment was that the jar that was fed with the carbon monoxide would be the one that heated up faster, and that did turn out to be right. I will go ahead now and go into the questions that were asked of this lab. The first question was, how does the greenhouse effect work? And how does the mechanisms different from what happens in an actual greenhouse? The greenhouse effect is a process that occurs when it goes into the Earth's atmosphere. It traps the sun's heat. This process makes the Earth much warmer than it would be without an atmosphere. This makes the Earth a tolerable place to live. An actual greenhouse would be on a larger scale, but if it was allowed to get too hot, then it would start to kill the animals, plants, etc. that were inside of the greenhouse. So it definitely is showing you on a smaller scale with the jars, but a larger scale with an actual greenhouse. The second question was, what are the sources of the experimental error in this procedure? Can all sources of error be eliminated? All sources cannot be eliminated. You definitely can try, but all of them cannot be eliminated. With all the ingredients, only variations could differ the results. The amount of light, how hot the bulb is, amount of baking soda, amount of vinegar, how well it's sealed, size of the jar, what the jar is made out of, all those could affect your experiment. And realistically, you just can't eliminate all of those. The third question was, did you expect the carbon dioxide in the air to reach a higher temperature? If so, explain why. Did your observations match the predictions? If not, explain why this may have happened. I did expect that this would happen on a small scale, and it definitely did. They did because it expected it to rise with more, the temperature to rise more with the gas than it did with the air, and that was exactly what happened. So it definitely was proven with my experiment. Does the experimental procedure provide an adequate model of the Earth's atmosphere? Yes, it does, because it is trapped by the Earth's atmosphere. If the Earth's atmosphere was not there, then it would not heat up the same way. The jar simulated the atmosphere, and then the gases simulated, being able to trap that heat. And it definitely showed that with those gases being added, that the heat was being able to be trapped. What are some of the properties of the jar that might have impacted your results? I said the thickness, kind of glass, how well it was cleaned, how big the jar was, etc. There's a lot of different properties that could have impacted our results. How close the jar was to the light, any of that could definitely impact it. On to number 6. Since the jar with the carbon dioxide is mostly carbon dioxide, while the jar with air has roughly 0.039 CO2 percentage, why do we only see a relatively small difference in temperature after 20 minutes? Does this mean that we should not worry about excess carbon dioxide in the Earth's atmosphere? It definitely, you only saw a small difference within 20 minutes because we had, a controlled experiment that we were doing, but we definitely should be worried about excess carbon dioxide in the atmosphere atmosphere, because even the littlest spike in a temperature could definitely change the way plants, animals, all that grow in our world. And any kind of difference could definitely make people sick, cause different plants to quit growing. All those sort of things could definitely happen. So we should be worried about it. Are all greenhouse gases equally as effective at trapping heat? All of them are not as effective at trapping heat. They go in this order is what I found. Methane traps the most heat, then nitrous oxide, then CO2, then water vapor. Of those, carbon dioxide stays for about 20 to 200 years, methane for about 12, nitrous oxide for about 114, and water vapors, they tend not to stay as long, but they do trap a lot of heat. That's definitely, I would be the most worried about methane since it does trap the most heat, but it does not stick around along the others, so that's kind of objective as to which one you should be the most worried about. But I definitely would worry about all of these, just because if they're trapping too much heat, the Earth's temperature is going to go up, and then plants, animals, all that sort of thing will die, and then that will cause us a huge issue as far as food sources, any of that sort of thing. That's just a brief overview of what we did for this lab. I definitely think that this lab was a great way to show how greenhouse gases affect our atmosphere and where we would be without them. Again, I tried to download a little bit longer video, and it said that it was too long to be uploaded, even though it was only about 10 minutes. So this is just a brief overview that I put in. I will also attach my references. Thank you for watching.